Hi, I'm David from the Universidad Autónoma de Madrid, and I'm going to show you a demonstration of how a gaze gesture recognition system that we have developed works. We are at this current implementation using a head-mounted setup in which basically we employ a webcam, a very cheap one. It costs less than 30 euros, that it simply lacks an infrared filter, and it has infrared LEDs that improve image contrast for the image recognition routines. For the gaze tracking engine, we use the open source ITU gaze tracker developed at the IT University of Copenhagen, and yeah, this is a demonstration of how our gaze gesture recognition engine works. So basically, we hook up this webcam to the computer, and in the head-mounted setup, we just place the webcam in this cap. We place it over our heads, and we opened the ITU gaze tracker. We will have to go through a calibration procedure, and here is the tracker working. As you can see, the infrared illumination helps a lot the image recognition routines to discriminate the pupil from the iris, and we are already reaching a pretty consistent calibration of the pupil. So we are getting pretty good parameters. So now we're going to go through the calibration procedure I mentioned before, by which the gaze tracker creates a model of the point of regard of my gaze. The calibration procedure simply consists on the user looking at a number of points on the screen, and we start the calibration now. So we have completed the calibration. It's pretty decent, around 0.9 accuracy, not as good as expensive commercial trackers, but pretty good for a tracker that uses off-the-shelf components. As you can see, it is able to determine pretty well with a certain degree of noise where in the screen and I'm looking. And now let's work and let's show the gaze gestures recognition engine. So basically I'm going to try to perform these 10 gestures that have been prettified before, and that this description of why this dataset has been selected is provided in the literature about this work. And so we are going to start the engine, and I'm going to perform them in sequence from the top left to right and going down. So I'm going to start trying to do a C. Okay, now we don't really need any type of a special background. We can do this over any type of application. So I just performed it a C. Now I'm going to try to do a U. As you can see, recognition so far is pretty good, and performing the gestures is quite fast. Now I just did a U mirror, a C mirror, So I just performed those 10 gestures, and there was one mistake done. The recognition rate was 90% by a mistake that I did. And yeah, this is how the gaze gesture recognition engine works. There's an alternative. We could use a dwell time in order to facilitate the recognition algorithm. A dwell time consists of performing a fixation that exceeds a predefined threshold that we have selected in 500 milliseconds. And this is a bit inconvenient for the user because we have to use a dwell time both at the beginning and at the end of the gaze gesture, but it facilitates recognition. And it also makes the gestures take a bit longer. So let's see how it works. The system will provide us with feedback information when fixation is detected. So with this I completed the 10 gaze gestures, and as you can see we reach a 100% recognition rate. So this way of doing it with a dwell time may be a bit more inconvenient, but it's more robust in terms of accuracy. And with this I conclude this presentation about gaze gestures. So thank you for your attention.